In recent years, we have witnessed an increase in virtual reality's popularity thanks to the accessibility of new VR devices. These devices offer visually immersive experiences that make you feel that you are right there in a digital environment. But will you still feel that you are there in an environment where it lacks a sense of touch? In this research, we focus on exploring the potential of stacked retargeting, a technique enabling low-cost VR haptic solutions by using everyday objects and leveraging visual dominance over other sensory information. Hello and welcome to my talk. My name is Aldrich, and this research is done together with my co-authors, Jarrod, Max, and Michael. Our paper introduces stacked retargeting, a concept enabling broader use of physical objects for VR haptic feedback. By leveraging redirection across various user movements, we aim to enhance haptics in VR for a wider range of virtual objects, all without the need for a complex setup. In this research, we present a staged approach to implementing stacked retargeting, redirected walking approaches that enable users to arrive anywhere at the site of interaction, and a usability magnitude estimation evaluation for these techniques. To give a little context, the term redirection in VR typically refers to a method that alters the user's perception of their movements. This is achieved by leveraging how the human brain prioritizes visual information over other sensory information. Previous research has looked into applying haptic retargeting through hand redirection, allowing a physical object to serve as haptic feedback for multiple virtual objects at a different location. Essentially, a subtle visual offset is applied as the user is reaching to achieve such remapping of haptics. However, this approach has limitations. While hand redirection supports haptic remapping, there is a certain magnitude of redirection that can be applied before being detected and interrupting the user experience. For example, prior work reported that the user's reach can only be redirected up to 15 degrees before being known to the user. This limits the scope of a physical proxy to support the haptics of only virtual objects in its immediate vicinity, which we refer to as the haptic coverage. Now, imagine our user has an empty coffee cup on a table, and we, the VR designers, wish to use this cup as a physical proxy for a vase in our application. Currently, the intended location for the vase is outside of the coffee cup's haptic coverage. This means that if we were to use haptic retargeting, the user would notice the effect and their overall experience would degrade. We could move the vase virtual position to be closer to the coffee cup's position so that haptic retargeting could be supported. However, this may clash with the narrative or broader design of the VR experience. This scenario showcases that relying on hand redirection alone means we either require many physical objects to represent a virtual environment, or haptics may not be provided for those virtual objects outside of the haptic coverage of a physical object. Hence, this limits the use case of haptic retargeting. To overcome these limitations, we propose stacked retargeting, a solution that combines multiple redirection techniques, particularly redirected walking and hand redirection, to enable haptics anywhere on an interaction site. So, how do we apply stacked retargeting? Well, this can be applied through multiple steps of increasing complexity to address misalignments between objects. First, we assess whether the physical object can provide haptic feedback for the intended virtual object. This involves determining whether the physical object is reachable and checking whether applying hand redirection to scale the reaching distance can solve the alignment issue. Next, we can check whether the virtual object falls within the haptic coverage of the physical object. If the virtual object is within the haptic coverage, we can simply apply hand redirection. If not, we need to combine redirected walking and hand redirection for the application of haptic retargeting. Before applying redirected walking, we must determine the location where the user should arrive near the physical table. This will inform us the total redirection needed to misalign the user's physical orientation and position from their location in VR. In our paper, we propose a solution that identifies a reach origin point in the physical environment, allowing the user to perform physical and virtual reaches that are relatively similar in direction and distance. By assigning the user to physically arrive near this origin point, we can subsequently apply hand redirection without being known. We propose various redirected walking solutions tailored for stacked retargeting. Specifically, we present two direct solutions which take a single walking path and apply rotation either at the beginning or during the walk. Additionally, we propose three compound solutions which support larger redirections and introduce waypoints along the route for additional rotational gains. These solutions are built on existing redirected walking techniques such as rotation gain, curvature gain, and translation gain, and therefore inherit the limits of redirection that can be applied without being detected. However, our solutions have the flexibility to apply the required redirection to the user's orientation and position separately, which is necessary for stacked retargeting. One such solution is turn and arc, which involves initial turning to face the virtual table, followed by curvature gain to reach the designated endpoint. Another direct solution is walk while turn, which applies separate redirection to the user's orientation and position as they walk. Depending on the final location and the required redirection, this solution may reorient the user to physically walk sideways as they approach the table. Next, we have compound solutions that rely on rotation gain to achieve redirection. One such solution is the L-shaped path, which introduces a waypoint to approach a table and displaces the virtual table from its physical location. Typically, redirection is applied as the user turns at the waypoint and the user's walk is scaled to arrive at the designated final location. Turn walk turn is another compound solution that adjusts the user's turning movement. This solution applies scaling as the user turns to approach the endpoint initially, and again as they turn to face the table. Finally, zigzag applies scaling to the user's turning movement at multiple points as they walk. I invite you to read our paper for more details on these techniques, including how to determine the user's location and the steps to apply stacked retargeting. We conducted an evaluation to investigate stacked retargeting, specifically to assess the effect of stacking multiple redirection techniques within perceptual limits on the user experience, and quantify the impact of different redirection techniques on walking dynamics so that VR designers understand the relationship between haptics and user interaction. Our evaluation involved participants experiencing all 5 of our proposed redirected walking solutions. We designed a task where participants walk from a starting point to a table and perform a reach interaction. This interaction allows redirection to align a physical object with a virtual object that is 22.5 degrees away, with the start button being the origin of orientation. When relying solely on hand redirection, users may detect a visual offset, as prior research suggests that typically our reach can be redirected up to 15 degrees to remain imperceptible. For each experience, we collected data on participants' walking behaviors and asked for their feedback through usability magnitude estimation and a semantic differential question. This enabled us to assess whether stacking techniques necessitate new redirection limits or if current known limits can be combined to expand the use of haptics. I will now present a brief overview of the results. Overall, our study confirmed that stacked retargeting expands the haptic coverage of physical objects, allowing the reuse of these objects for a wider range of virtual objects. Furthermore, our evaluation revealed that stacking redirected walking and haptic retargeting under the perceptual threshold does not degrade the user experience and has minimal impact on the user's walk. However, this depends on the redirected walking solutions applied. We observed that participants generally rated their experiences more favorably with compound redirected walking solutions than with direct solutions, despite the additional interactions required. This preference suggests that redirection applied during turns is less perceptible than continuous rotation applied during walking. Notably, the walk while turn solution received the lowest ratings compared to other solutions. This outcome is likely due to the continuous application of separate redirection applied to the user's orientation and position. This highlights the need for further investigation into its limits and knowing the maximum range that can be applied without being known. For a broader discussion on the application of stacked retargeting and its trade-offs, I invite you to check out our paper. However, if there must only be one takeaway from this research, it should be this. We can leverage redirection techniques for multiple virtual objects across different locations to share a single physical proxy. While individual redirection techniques have limitations, stacked retargeting demonstrates that combining them enables haptics anywhere on an interaction site without users noticing redirection. This research on low-cost haptics with redirection represents an important step towards realizing the ultimate immersive VR experience.